Wireless devices of today are amazing, but before we look at how various wireless technologies work, we should get a better understanding of network concepts. In this first lecture, we will take a step back and look at the anatomy of the internet. Specifically, how does data get from my mobile device to the global internet? We'll also reinforce a little bit of terminology along the way. So let's walk through things, shall we? Let's start off and look at how does this lecture get from a streaming video to you, the student, from edX to your mobile device.
What are the important questions in wireless?
How do wireless networks connect our tablets, smartphones, and laptops? First, we start off with our mobile device, which is a node on the network. This device connects via a wireless link across the local area network, or LAN, to get onto the internet. The wireless connectivity might be coming from either Wi-Fi that's provided via an access point, or perhaps via a cellular link that is provided by a base station. The wireless link is what is known as the last mile, namely the last hop between my mobile device and the global internet. While we are going to come back and focus on the wireless technologies of the last mile, let's peek a bit behind the curtain and see what happens once my data gets onto the internet. Our wireless link serves as a gateway or an on-ramp to get our data to and from the global internet. If you look at the internet itself, it's really just a collection of networks, nodes, links, and devices that in turn are connected together by a larger global network. We call this kind of network a WAN, or wide area network. Our local area network, or LAN, which was the wireless hop, that's what's got us onto the bigger and broader internet. Usually when we think about the internet, we tend to think of it as a cloud. We put data in on one end and data comes out the other side where we would like it to go. Much like when I make a phone call or send a letter, we pick a destination and then we let the network take care of the work of getting it to its destination. In reality, when we look at it, the internet is actually a group of networks, or in what we call networking parlance, autonomous systems. These internet service providers are responsible for peering with one another and exchanging data. Then they all work together to shuffle our data across the network. Various networking protocols then govern how the data is routed between the various autonomous systems. The internet itself is essentially a confederation, or a group of willing ISPs who all more or less agree to play by the same rules or protocols as everyone else. If you think about it conceptually, it's more like Star Trek and the Federation and a little less like Star Wars and the Empire. There's no central entity that really rules the internet. These rules then govern how our data is broken up into bite-sized chunks called packets, and they're sent from our mobile device out to the internet. At each node along the way, individual nodes decide which link to send the packet on in order for the packet to make its way over to the destination. We call this overall process routing, which is how individual nodes in the network then decide the next hop and how to send packets to get them on their way to their destination. The data transfer typically takes place between what we call a server, the one that actually has the content, and our client, our device. This constitutes what is called a flow, and the packets that make up that flow follow a path that we call the route. For our mobile device, the path that started at the edX server that had our streaming video carried it across the internet then until it reached our last wireless mile, and which in turn delivered the content to our mobile device. In our next modules, we'll look deeper into the wireless last mile and how our local area network then operates as part of the broader internet. The use of packets was a fairly significant shift from the telephone networks that were used in the past. In the public switch telephone network, or the PSTN, we would set up a circuit then between the two parties that wanted to chat. That means that for every conversation that we wanted to have, we would have to wire the circuit, either directly via actual wires or virtually via software, creating state in the nodes before we could actually send any data. For doing something as simple as sending a text message or downloading a web page, the very process of even just setting up a circuit could actually take longer than just moving the entire data. Now, by switching over to a packet-based approach, where each packet contained where it was going and where it came from, that made things much easier to move along the entire path. Much like when you take a letter and you drop it in the mail does not worry about where it's been, it just is worried about the next hop. And conceptually, what happens then is each router in our path then looks at the destination address and figures out how to forward it on towards its destination. These decisions are governed by routing protocols that occur both at the level of routing between internet providers, what we call inter-domain routing, something like, say, a provider such as level 3 to Comcast, and then within an ISP, or what we call intra-domain routing, or say within a provider such as China Mobile or Verizon Wireless.